Hello, and welcome to G Fun Facts Online. For most of human history, the stars were just tiny, glittering dots in the night sky. The idea of planets orbiting them, let alone knowing what their skies looked like, was pure science fiction. But we are living in an incredible time. Right now, we are standing on the edge of a new frontier, moving from simply finding these distant worlds to actually reading their skies. We're talking about decoding alien weather, climate, and the very air of planets light years away. So how do you possibly see the atmosphere of a planet you can't even directly see? It's a huge challenge. Imagine trying to see a firefly buzzing around a searchlight from miles away. The star is a billion times brighter than its planet. But astronomers are clever. The most common trick is called transit spectroscopy. When a planet passes in front of its star from our point of view, a tiny bit of starlight shines through its atmosphere. Different chemicals in that air absorb different colors of light, leaving a unique fingerprint. If water vapor is there, it blocks some red light. If there's titanium oxide, it might absorb yellow light. It's like a cosmic barcode that tells us what's in the air. There are other methods too, like directly taking pictures of huge, young planets that are still glowing hot from their formation, or using subtle shifts in starlight to tease out the chemical signals. And this whole field just got a massive upgrade with the launch of the James Webb Space Telescope. The JWST is like swapping a pair of old binoculars for the most powerful telescope ever built, and its impact has been immediate and mind-blowing. For example, on a young, giant exoplanet named YSES-1c, Webb found the strongest evidence ever for silicate clouds. That's right, clouds made of tiny, sand-like particles. And it didn't stop there. For another planet, a scorching hot world called WASP-121b, JWST created the first ever 3D map of an alien atmosphere. It revealed powerful winds whipping iron and titanium across the planet, creating complex weather patterns we could only dream of seeing before. And just recently, it took a look at a planet called TOI 270d. Scientists thought it might be a Hycean world, a water world with a hydrogen atmosphere. But Webb's data tells a different story. It's more likely a massive rocky planet with a thick, scorching hot atmosphere over 1,000 degrees Fahrenheit, full of carbon dioxide, methane, and water. This is a whole new level of planetary science. The innovation isn't just happening in space. Back on Earth, new instruments are acting as scouts for Webb, finding the best planets to study in detail. And to handle the flood of data coming in, scientists are turning to artificial intelligence. Special AI models, called physics-informed neural networks, are helping us understand how light scatters through alien clouds with more accuracy than ever before. There's even a clever new method that just looks at a planet's temperature. If its hot side isn't as hot as it should be, it's a good sign that an atmosphere is there, spreading the heat around. Now, it's not all easy. Looking at the atmospheres of smaller, cooler, Earth-like planets is still incredibly difficult. The signals are minuscule, but the ultimate goal is within sight: the search for biosignatures. These are combinations of gases, like oxygen and methane together, that are hard to explain without some form of life producing them. The next few years are set to be a golden age for studying alien skies. With every new spectrum analyzed and every new world decoded, we get one step closer to answering that profound, ancient question: are we alone in the universe? Thanks for listening to G Fun Facts Online.